Welcome to today's class. Today's class is absolute value inequalities. So absolute value inequality part 4. I have done absolute value inequality part 1, part 2, part 3. And in part 1, 2, 3, I have solved 4 examples. So in today's class, I'll be looking at the remaining 2 examples, which is number 5 and number 6. So I would advise if you have not gone through part 1, part 2, part 3, endeavor to do that so that you understand part 5 and part 6 better. So looking at the question on the board, solve the absolute value of 4x minus 3 is greater than minus 4. Again, looking at this, the solution is all real values of x. All real values of x. And why is this so? The reason is that whenever an absolute value expression is given, the solution will either be 0 or greater than 0. The solution cannot be negative. The solution must be either 0 or greater than 0. So for that reason, it therefore means that any value of x you put, this statement will be true. In other words, the solution to this question is all real values of x. But assuming you don't know that that is the answer and you want to solve it, you can still solve it. Recall, if you go through part 1, I made a statement that when it involves greater than, you use the word or. When it involves greater than, use the word or. So looking at this expression, it can be written as 4x minus 3 is greater than minus 4, or 4x minus 3, you change the sign and also change the sign of this number, so it will become positive 4. That's why I'm saying if you go through part 1, part 2, part 3, you understand why we changed this. Alright, so from here, if we move negative 3 over to this side, we'll have 4x is greater than minus 4 plus 3, because when negative 3 crosses over to this side, it will become positive. Or 4x is less than 4 plus 3. When negative 3 crosses over to the other side, to become positive. And so this will give us 4x is greater than minus 1. Negative 4 plus 3 is negative 1. Or 4x is less than 7. At this point, divide both sides by 4. We'll have x is greater than minus 1, or x is less than 7 over 4. So assuming we want to express this on a number line, assuming we want to express that answer on a number line, we are going to have something like this. This is negative infinity. This is positive infinity. And so if this place is minus 1 and this is, let's say, 7 over 4. So x is greater than minus 1. All the numbers this way are greater than minus 1. So the arrow will go this way. It will go that way. And then the circle will not be shaded. And for this one, x is less than 7 over 4. All the numbers this way are less than 7 over 4. So the arrow will go this way. It will keep going to negative infinity. So that is why I'm saying all real values of x will give you the answer. So therefore, the solution set, is x is such that x is greater than minus 1 union x is such that x is less than 7 over 4. Another way of keeping this answer is from negative infinity to positive infinity. This is also another way of keeping the answer. So that is the answer for question number 5. For any value of x you pick, the statement will be true. That's why we are saying all real values, all real values. You can test it with any number. Put it here. Recall the absolute value expression should give you an answer that is either 0 or greater than 0. For a number to be greater than 0, it simply means the number is positive. So that's why I'm saying any value you pick, this statement will be true. We can test with a number like 5. You put 5 here. Why 5? Because if you say negative 1, x is greater than negative 1, 5 is part of it. 5 is part of it. So any number you pick that is greater than negative 1, put it here. This statement will be true. Any number that you pick that is less than 7 over 4, put it here. The statement will also be true. So quickly, let's look at question number 6. Go back to question number 6. 3 times the absolute value of x minus 2 all over 5 minus 3 is less than 6. What you do at this point, try and see how you can express this or write this expression so that absolute value will stay alone, to stay alone. So for us to do that, I'm going to move this negative 3 over to this side, and that will give me 3 times the absolute value of x minus 2 all over 5. Moving negative 3 to this side, you have less than 6 plus 3. And so this will give us 3 times the absolute value of x minus 2 all over 5 less than 9. 6 plus 3 is 9. At this point, the absolute value sign is not still staying alone. So I must look for a word removing this 3. And the only way you can remove this 3 is by dividing both sides by 3. If you divide both sides by 3, you have the absolute value of x minus 2 all over 5 is less than 9 over 3. You are dividing both sides by 3. This side divided by 3 to cancel out. So this will now give us the absolute value of x minus 2 over 5 is less than 3. At this point, we can now solve it because the absolute value sign is staying alone. Now, if you go through part 1, I made a statement in part 1 that when it involves less than, you use the word and. Anytime the word and is used, it means the solution can be combined. The solution can be combined. And I also said, if you don't know if you should use the word and, that is and, or you should use the word or, you can always solve it. When you arrive at your answer, check if it is possible for the two answers to be combined or not. If it is possible to be combined, you use the word and. If it is not possible to be combined, you use the word or, that is or. So let's solve this. This will now be x minus 2 over 5 is less than 3. The word and will be used because of this sign. Then x minus 2 over 5. You change the sign and also change the sign of this number. Okay. Now at this point we cross multiply. If we cross multiply, we'll have x minus 2 is less than 15 and x minus 2 is greater than minus 15. All right. Okay. Now, if we move negative 2 over to this side because we want x to stay alone, we'll have x is less than 15 plus 2. Because when negative 2 crosses over to this other side, it will become positive. Or it will become positive. And x is greater than negative 2 moves over to this side, it will become positive. And so x is less than 17 and x is greater than negative 18. As you can see, it is possible for a number to be less than 17 and at the same time greater than minus 18. So when it is possible, we use the word and. If it is not possible, we use the word or. So therefore, the solution set is x is such that x is less than 17. Okay, it can be combined. If it can be combined, the word and is used, so it can be combined. X is such that minus 18 is less than x is less than 17. That's the answer. That's the answer. And you may be wondering, why am I expressing it like this? Minus 18 is less than x. What is yes? X is greater than minus 18. So why am I expressing it like this? Let me use a typical a number like this. If I write x is, okay, let me use a number. If I write 10 is greater than 6. Now, if I express 6 first, will I still maintain the sign? Of course, no. So if I write 6 first, this will now change to 6 is less than 10. So that's what happens here. X is greater than minus 18. If I write minus 18 first, the sign will change to less than. That's it. So minus 18 is less than x. That means that that is the solution to question number 6. So with this, we have come to the end of this class. We have come to the end of absolute value inequalities. So if you are coming across my video for the first time, please do well to subscribe, like, comment, and share. Then if you have any challenge on quadratic inequalities, you can always drop it on the comment section. Then I will attend to it. Thanks for watching.